First example, x equals say 2t squared, y equals 7 plus 2t. Now we say that identify the graph. Since we are familiar with algebraic functions or Cartesian form, so we'll try to transfer this onto Cartesian form. So from this you can see we need to eliminate t basically. So t will be y minus 7 over 2, and then put it back in equation 1, 2 times y minus 7 over 2 squared. So you get x equals, this is 2, this one will be 4, and you can say y minus 7 squared. You can leave it like that. So then finally it will look like 1/2 y minus 7 squared. Now if you compare, you can see that this one I have mentioned in number 5, form 5. So compare with form 5, like x equals b y minus h squared plus k type. Yeah, if you compare with this, you can say that b is 1/2, h is 7, and k is 0. So then we know that this is the equation of a parabola that will go like the vertex is 7, 0, so it is here, and then it is actually going like this. So this is the parabola, form number 5. Make sense? Okay, so I'm going to the second example. X equals say 3 cosine theta and y equals 9 sine theta, and then make relation between x, y. That is the form in Cartesian. So the first equation I can say x over 3 is cosine theta, and y over 9 is sine theta. Now if I just square and add, you get x squared over 3 squared plus y squared over 9 squared equals 1, right? Because the right hand side is cosine squared theta plus sine squared theta, which is 1. And what is it? An ellipse. This is an ellipse, and the center of the ellipse is at 0, 0. And then you can see here a is 3, b is 9, so b is bigger. So then when you plot this one, it will look like this. Stretch will be on y-axis because y value here is 9. So this is 9 and this is 3. So you're going like this. Now for example, we are also giving you that plot this one now with the restricted boundary. Use negative pi by 2 lesser or equals theta lesser or equals pi by 2. We know that it is an ellipse using Cartesian form. We just see that if theta is negative pi over 2, then my x will be 3 cosine negative pi over 2. And we know that cosine pi by 2 is 0, so this one is 0. And then y will be 9 sine negative pi over 2. So you get negative 9. And you can remember negative pi by 2 will be here, and then pi by 2 will be here. So we are going from negative pi by 2 to pi by 2. That means 0 is in between, isn't it? So then our angle is here on this. And in the Cartesian form now we see that when I have these values, so x is 0 and y is negative 9. So this is the point here, 0, negative 9, and we call it initial point. Same way when you say theta equals pi by 2, same way x will be here 0 and y will be 9. So you get a point in here. So then your graph is actually going like this, and it is a semicircle because with the restricted domain. Okay, so you got a semicircle, and this one is going now counterclockwise direction. In this direction we have plotted this. right? So this is actually going to form 3, where you have mentioned ellipse. I'm going to the next example. X equals 7 secant theta and y equals 7 tan theta. Now this is coming with secant and tan. So remember that secant squared theta minus tan squared theta equals 1. So first let us isolate secant and tan, and also they are same, so if you don't isolate it's still fine, but it is a good practice. Isolate secant theta, y over 7 is tan theta. Now we need to square and subtract because I want to get this, because it is now secant squared theta minus tan squared theta, which is 1, and this one is called hyperbola, right? This is hyperbola. Center will be at 0, 0. All right. So you got this one, hyperbolic form. Now I take next problem, 3 star. Now we put some restriction here. We say that negative pi by 2 theta between pi by 2. Now I'm not taking equal sign because tangent pi by 2 is undefined, so we keep it open. If it is like that, so what is your initial point? You can see theta equals negative pi over 2 approximately. I'm not going close. Maybe better will be you take negative pi by 4, okay, because pi by 2 is undefined here. So then what happens? X equals 7 secant negative pi over 4, and you know that secant is reciprocal of cosine, so secant pi by 4 is same as 1 over cosine pi by 4, right? And we know that cosine pi by 4 in this case it will be just radical 2, because cosine pi by 4 is radical 2 over 2, and then ultimately you are getting 2 over radical 2. After simplification is just radical 2, and cosine is even function, so if you have a negative here, that negative goes away. So then x equals 7 radical 2, and then y will be 7 tangent negative pi over 4. I'm using reference angle. Tangent is odd function, so negative will go in front, so it will be just negative 7. Tangent pi over 4 is 1. So you get negative 7, that is your initial point. Okay. Now when you look at the plot, you will see, and the terminal also you can find same way. Finally you will see that we are going from negative pi by 2 to positive pi by 2. So we are here. All right. When it is negative pi by 4 somewhere here, angle, so that case your 7 is, x is 7 radical 2 somewhere here, and this is 7, so you get a point in here. When you go to pi by 4, so you get the same answer, 7 radical 2, and then y value will be positive, so then it will go here. And then you can see that our graph actually goes like this. And we say that it is hyperbola, isn't it? This is the hyperbola. So hyperbola has this side and this side also. So the left side we are not taking because of the restricted domain on this, so only one side. So initial point we have found here, and then terminal on this. So that's why it is going in this direction, because it is going like this, right? This is a clockwise direction. Yeah.